Hello everyone, welcome back to my YouTube channel. I am Manpreet Singh and you are watching Physics World. So, in today's lecture, what we are going to discuss is this projectile motion lecture number 2. So, I have written a statement or a law or a principle in front of you. This is principle of physical independence of motions by Galileo Galilei. So what this principle say is, this principle said that the horizontal motion and the vertical motion of a projectile motion is independent from each other. That is, the vertical motion does not affect the horizontal motion and vice versa. So we are going to write the statement said by Galileo back in 16th or 17th century. Yes. So what is the statement for the principle of physical independence of motions? First of all, you have to write this statement because this is very important. This is given in NCERT and a question come in my examination to explain principle of physical independence of motions. So let's write this statement. So this is the statement of principle of physical independence of motions. So the two motions of a projectile along a horizontal and vertical directions are independent of each other. This is called the principle of physical independence of motions as stated by Galileo Galilei. So what this statement means, this statement means that if we have a projectile, let's suppose we have a projectile like this. Let's suppose this is the y-axis and this is the x-axis, right? And we have a projectile like this. This is our projectile. Okay? So this statement means that if if the velocity at point P, let us say the velocity at point P, and let us magnify this velocity. Let us magnify this velocity at this point. So this is like this. This is the original vector which we have resolved into two rectangular components. This is the original vector, say vector v, yes, and this is angle theta. So this is v cos theta and this is v sin theta, right? So this statement means that v cos theta component and v sin theta component of the v vector is are independent of each other. That is, neither v cos theta affect v sin theta nor v sin theta affect v cos theta. These two are independent. How we can conclude that? We conclude that because we know that v sin theta, that is this component, vertical component, changes. Vertical component has an acceleration downwards, that is g, right? And this, due to this g, the velocity vector in the vertical direction decreases till this point and then decreases further from the one quadrant, from the next half journey. Okay? But v cos theta on the other hand remains constant throughout the journey. Yes. So this means that v cos theta and v sin theta are independent. Neither v sin theta is changing, but v cos theta is constant. V sin theta is changing with respect to the time, but v cos theta is constant throughout. My handwriting is poor, I know that, but you understand this, you can understand this, that v sin theta is changing, not constant, but v cos theta is constant. This means they both are independent of each other. I hope that's clear. I hope that's clear. There is a very beautiful example to show this. What that example is, suppose you are on a building. You are on a building. Yes, there is a guy. There is a guy over the building. बड़े बड़े बाल है उसके, उड़ रहे हैं हवा में. Yes, and he or she, don't be like मतलब डिस्क्रिमिनेशन नहीं है यहाँ पे, ठीक है. तो he or she throws or let us drop a stone. Stone is larger than its surface, than its face. Oh my. So he drops a stone downward. Drops means u equals 0 in this case. Yes, and this he drops down, and at the same time, simultaneously, another guy throws a ball horizontally with horizontal velocity, not vertical. He doesn't provide any vertical velocity. See this. One guy, this not this, ठीक है. One guy क्या करता है वो? He just drops the ball. He just drops the ball or object or stone what you are shoot with. So he just drops the object, and another guy he throws the stone, he throws the object by applying only horizontal velocity, only horizontal, not vertical, like this. I don't provide any vertical velocity, I only provide the horizontal velocity of the stone or the object. I don't apply any vertical velocity in the second case. So what's happened is, when the experiment happened, we observed that both the stones, both the objects, neglecting air resistance, both the objects, irrespective of having any masses, reach the ground in the same time. That what means that in this case vertical velocity is 0, horizontal is also 0, but we are not convinced, we are not required to do that. Horizontal velocity we are not supposed to, just forget it. Only vertical velocity is 0 in the first case, and in the second case also vertical velocity is 0. We only provide the horizontal velocity. So this means that both the cases are equal according to the statement. Horizontal component does not affect the vertical component according to the statement, and that what happens, time is same for both the objects. फिर से सुन लो, एक बार फिर से सुन लो, हिंदी में सुन लो एक बार, हिंदी में बता देता हूँ, इंग्लिश बहुत बोल ली अभी. देखिए हो क्या रहा है, दो ऑब्जेक्ट्स थे, ठीक है, दो ऑब्जेक्ट्स थे, मास जो भी हो, क्योंकि हमने एयर रेजिस्टेंस को हटा दिया है, तो मास चाहे किसका भी बड़ा हो किसी का भी छोटा हो, दोनों सही सेम टाइम पर ही नीचे पहुँचने हैं, ठीक है. इतना तो आपको 9th स्टैंडर्ड से पता ही है. अब उसने क्या करा, एक बंदे ने क्या करा, जो ऑब्जेक्ट था उसको सीधा नीचे फेंक दिया. तो इसमें वर्टिकल वेलोसिटी तो 0 ही, हॉरिजॉन्टल का हमें नहीं पता, हॉरिजॉन्टल को हम देख भी नहीं रहे, ठीक है. और दूसरे वाले केस में भी वर्टिकल 0 थी, लेकिन हॉरिजॉन्टल थी, हमने हॉरिजॉन्टल वेलोसिटी से फेंक दिया था उसको. हॉरिजॉन्टल तो थी बट वर्टिकल नहीं थी, और दोनों को हमने सेम टाइम पे फेंका, t=0. तो हम क्या ऑब्जर्व करते हैं कि दोनों सेम टाइम पर ग्राउंड पे पहुंच रहे हैं. वो बात अलग है कि डिस्टेंस तो दोनों का अलग अलग ही होगा, एक थोड़ा दूर गिरेगा, एक तो नीचे गिर जाएगा, लेकिन टाइम दोनों का सेम लगा. इसका मतलब क्या, हमने दूसरे वाले में हॉरिजॉन्टल वेलोसिटी लगाई, वी हैव पुट द हॉरिजॉन्टल वेलोसिटी, लेकिन बट द हॉरिजॉन्टल वेलोसिटी डजंट इफेक्ट द मोशन, doesn't affect the vertical motion. We are considering about the vertical motion, not horizontal. We are only considering वर्टिकल मोशन। हॉरिजॉन्टल मोशन तो चेंज हो गया ना, हॉरिजॉन्टल मोशन तो चेंज हो गया, पहले वाले का क्या था, हॉरिजॉन्टल डिस्प्लेसमेंट कोई नहीं था, देयर इज़ नो हॉरिजॉन्टल डिस्प्लेसमेंट, बट सेकंड केस में देयर इज़ हॉरिजॉन्टल डिस्प्लेसमेंट, देयर इज़ हॉरिजॉन्टल डिस्प्लेसमेंट। आई होप दैट्स क्लियर, आई होप दैट्स क्लियर, बिल्कुल क्लियर हो गया होगा कि कैसे प्रिंसिपल ऑफ फिजिकल इंडिपेंडेंस ऑफ मोशंस को हमने एक्सपेरिमेंटली प्रूव किया। ठीक है, दिस स्टेटमेंट इज proven by Galileo experimentally. Galileo was a scientist, was a physicist actually. He believes in experiments. He do many experiments, and this is one of his experiments. I hope that's clear how vertical and horizontal components are not dependent on each other. Yes, so let's move on to another topic where we have to discuss about the range, time, time of flight, and maximum height of a projectile thrown at some angle, that is oblique projectile motion. So that's the most important topic of the chapter of motion in a plane. Let's move on. So now we are going to derive some equations related to the projectile motion. So first of all, we are writing the equation for the trajectory of a projectile motion. Trajectory is the path, the equation which tells the path, which tells the position of projectile. So first of all, remember that in a trajectory equation, in any trajectory equation, any trajectory equation, there is no time expression, there is no time expression. We don't consider time in trajectory equation of any particle traveling in any kind of motion. So this is the trajectory of projectile motion, so this does not include the time. So first of all, clear that the time is not considered in any trajectory equation. Yes. So what is a trajectory? Trajectory equation tells us that y-axis and x-axis dependency. Okay, that when y is this, what is the value of x? Means that when the projectile is let's say about 5 meter in the horizontal direction, the projectile motion has traveled the projectile the projectile has traveled the 5 meter in x direction. How high does it travel in the y direction? This is what projectile motion helps us in, trajectory equation helps us in doing these kind of things. So let's start the derivation of trajectory of a projectile motion. First of all, you have to note these two down. These are very important notes. These are very important notes, that horizontal motion is uniform. Uniform means velocity does not change over time. The velocity is constant. Vertical motion is non-uniform because there is acceleration due to gravity acting downwards. That is, u sine theta is not constant, but u cos theta is constant throughout the motion. Yes, you have to first of all note these two down. This is very important. Now let's move to the derivation, and this derivation is also useful for telling that projectile motion is a parabolic path. Yes, if someone asks you that prove that projectile motion is a parabolic path, then you have to derive trajectory equation. Then you have to derive what? Trajectory equation. Yes. So let us write the equations. First of all, what we are going to write is this. क्या राइट करें हम देखते हैं एक चीज, क्या? So we have assumed that the projectile has covered x distance in the horizontal direction and attain y height in the vertical direction. That means the projectile has reached point x where the coordinates are x comma y, x in the horizontal direction, y is in the vertical direction. So let's now write equations about these facts. So first of all, take the horizontal direction. Take the horizontal direction. Yes. What's happen in a horizontal direction? Let us write a simple equation for uniform motion. Horizontal motion is uniform, so horizontal direction is uniform. So for uniform motion, there is only one equation. There is only one equation. You have to remember that v equals s upon t, means that speed equals to distance upon time. Yes. So manipulating things here, we got that speed is u cos theta. Speed is u cos theta. Let us suppose speed is because it is constant, so speed is u cos theta equals to s is the horizontal distance covered by the projectile, that is x, upon t is the time taken to reach the point x. Yes. So I told you that we have to uh, eliminate the time expression. So what we have to do is we have to eliminate the time expression. So time expression को हमें क्या करना है, eliminate करना है. So we can write that t equals x upon u cos theta. Now we can put this in an equation and the equation becomes time independent. Trajectory equation is always time independent. So this is the first equation. Yes. Now we are considering the vertical direction. Vertical direction. Yes. What's happened in vertical direction? In vertical direction, we have covered the displacement of y. Yes, displacement y. In time t, time is the same for both because it reaches point t at simultaneously. Obviously, time is the same for both the uh, components. Yes. So the projectile has attained a y height at the time t. Yes. So we can apply the second equation of motion, I guess, because in second equation we are relating distance, velocity, and time. And time we can put from here to become the, so that the equation become time independent. Yes. So we can write that down. Yes. So let's write second equation of motion for vertical direction. Mark my words, for vertical direction. So yes, so s equals ut plus half at square. Yes. So displacement in the y direction is obviously y, and velocity in the y direction uy. What is uy? Uy is nothing but u sine theta. U sine theta. U sine theta is the velocity in the vertical direction. We have assumed that u sine theta. Then what happens is, then t multiplied by t, and t from this equation we can substitute x divided by u cos theta. Yes, you can write this plus half. What is a? Now a is your acceleration due to gravity that is acting downwards. That is acting downwards. So here we have to put a negative sign. And g t square t, we can write x upon u cos theta whole square. Yes, it is clear to you? Is it clear to you? Yes. So now we have to we have to multiply or divide and cut these expressions, simplifying the equations. So y equals sin theta upon cos theta is tan theta. So x tan theta minus 1 by 2 g x squared upon u squared cos squared theta. Yes. Is this clear to you? Is clear? Yes. So that's all. We have just now manipulating some things, that is x tan theta minus we can write gx square upon 2u square cos square theta, and this is our final equation of trajectory. Yes, this is the final equation for trajectory, that is y equals x tan theta minus gx square upon 2u square cos square theta. So so you can see that if you know the equation of parabola, you can see that this is constant. Tan theta is constant. Yes, tan theta is constant, and this g upon 2u square cos square theta is also constant. So this can be written as y equals ax minus bx square. We have assumed that tan theta is constant, g is constant, 2 is constant, u square cos square theta is also constant. So this becomes y equals ax minus bx square, and that is the equation for parabolic path. Parabola. Yes, parabola. This is the equation for parabola, and thus we can conclude that trajectory of a projectile is parabolic. Trajectory of a projectile is parabolic. This is the proof of that question. Yes, this can be asked in your examination. Prove that projectile motion, that a projectile is in a parabola motion. Yes, so this is the proof of that question. And also the question can be asked that trajectory equation को derive करो. So this is the derivation. And now note this equation down, because when we derive other equations in the next sections, because now this is over, this is done, now the class end here. So note these equations down. In the next lecture, when we derive range, time and maximum height, then an interesting things happen, that here we can relate range also. We can relate y, x and range also. How can we do that? We see in next class. So that's all for today's lecture. I hope you understand all the things, that is what is physical independence of motions and trajectory equation, and some basic concepts related to projectile motion, parabolic equation, horizontal motion is uniform, vertical motion is non-uniform, and all that things. I hope that's clear. Thank you very much. Best of luck for your bright and prosperous future. Thank you.